In this video, we'll use Rails generators to implement a Rails MVC pattern for displaying, editing, and saving user data. We'll also start using Trello to plan our tasks by breaking them up into small, manageable, and testable chunks. Let's go ahead and open up Trello. Log in with your Google account, or if you signed up with an email and password, click on the link below that. You'll now be greeted by your Trello dashboard. If you don't already have a board for the What Time Is It project, go ahead and create one now. You'll now see your to-do, doing, and done boards for the What Time Is It project. The board names are pretty self-explanatory. Let's set us up some tasks. To start off, I'll say we'll want to create a user model, and it should have a name and an email. I'll add those as an attributes checklist in the card itself. For now, let's just say that a user should have a name and an email. We'll add other attributes to it later once we've got things rolling. Then I'll take the user model out for a spin in a Rails console, and I'll do it in sandbox mode so it won't mess up with my actual development database. Next, I'll make sure that a user has its attributes and data validated. That is to say, I want the app to ensure that only valid data is saved for any user object. At this point in time, I'll probably want to ensure that a user provides a name and an email. The email should also be a valid email. Although most modern browsers will help filter out invalid emails in a form, it's always a good idea to have data validation done at the database level in case anything slips through the cracks. I'll add that task into the Validate User Attributes card's subtask checklist. Once we have a basic user model, we'll want to be able to view the user information in a browser. For that, we'll need some controllers and views. So we'll add a task to generate a user controller which should have an index action to list all users and a show action to view information for a specific user. We'll also need to edit the generated user views to have it display the information we want for each action. We'll be editing the index and show view pages. Before we go on, let's make sure to get our wordings correct. It should be users controller with an S, since Rails by convention expects your controllers to be in plural form, and here I meant to say edit the generated user views to show user information. Although I could have left it as it was and still be able to understand it later because I wrote it, someone else reading it might have trouble understanding unclear stories or tasks. So always make sure to write clear, concise, and contextual stories. Lastly, we'll presumably need some routes to tell our app what URLs to map to which specific actions in our controller. So let's add that story in here too. We're going to do this with test-driven development, so let's plan out our RSpec tasks here as well. We'll want specs for our user model, and let's just say here what we want to test. In this case, we'll want to ensure that the user model responds to the name and email methods. We'll move the card up on the board so it's above the actual implementation we'll eventually build to satisfy the test. Then we'll add specs for the user attributes validation. We'll validate the presence of a name and an email, and the format of the email. Move this card to its chronological order in the board. And finally, let's also write some specs for a user controller, which should test for getIndex and getShow, the two pages that we've planned to build so far. Let's move this up. Hang on, let me just fix this here. There we go. This now gives us a significant amount of stuff to do, so let's get to it. First, I'll assign myself to this task and then drag it over to the Doing column so that any other team members on this board can see what it is that I'm working on. So let's write the specs that we've assigned ourselves to write. We can quickly generate a spec file for our user model by using the Rails generate rspec:model command, passing it the name of our intended model, being user in this case. You'll see that the RSpec model generator created a user underscore spec.rb file under the specs/models folder. Let's open that and see what it looks like. Inside it is a generated RSpec describe block for a user model with a pending example in it. Let's try and run RSpec on this user spec to see if it runs correctly. Before this, we ran rspec spec, which told rspec to run all the specs under the spec directory. This time, let's tell it to run only the specs in our spec/models directory by running rspec space spec/models. Uh-oh, looks like there was an error. Let's take a look at what it says. The trick that every good developer uses when facing an error is to read the error's output. Here, it says uninitialized constant user, which seems to tell us that we're missing a user definition. We can generate one using Rails generate model. Let's do that now. Looks like Rails created a couple of files for us, a user.rb file under the app/models directory, and a migration file called create users with a timestamp preprinted to it under the db/migrate folder. Let's inspect each one more closely. Here we see a class user being defined that extends Active Record Base. Active Record Base provides a number of methods like new and find and where that let you interact with your users table to create records, edit them, and even filter them out, among many other things. You can find out more about Active Record Base or any other Ruby implementations at a great Ruby documentation site called OmniRef. Here, you'll see the Active Record Base module and some comments and documentation describing the methods provided by it. Now let's take a look at the Create Users migration file. What you'll find is a class with the same name as your migration, which inherits from Active Record Migration, and a change method definition with a create table and t.timestamps directives in it. Taking a look at Active Record Migration in OmniRef might help us understand migrations a bit more. Let's go have a look. Let's search for Active Record Migration and click on that. It says here that migrations are a way to manage your database schemas, which is a description of all the tables and their columns in your database. It also mentions that migrations have two methods, up and down, which describe the transformations required, in other words, the changes to be made to your database, to implement or remove the migration. Examples of transformations include add column, remove column, and add index. There's also some useful examples of migrations here, a list of available transformations, some examples of generating migrations using the Rails generate migration command, and here it talks about reversible migrations, which looks a bit more like what our Rails generate command made earlier. It says here that Rails is now able to use reversible migrations, where you just have to specify the up logic and Rails figures out how to do the down for it. So for reversible migrations, you use the change method. Scrolling down a bit more, you'll see a link to all possible reversible migrations. Click on that link to see what migrations you can use the change method with, instead of having to define up and down individually. Now that we know what this change method is, we should understand that this create users migration simply creates a table called users with some timestamp columns. The t.timestamps method generates the created at and updated at timestamp columns for your users table. So let's get this users table created. We already have a migration generated with our model. It's time to run it. Type rake_db:_migrate and Rails will tell you that it's successfully created a users table. You ought to be aware that the Rails server, console, and rake programs run in the development environment by default, which means that the migration we just ran created the users table for our development database. But we've yet to get a users table created for our test environment, which is the environment in which RSpec runs. To set up your test database to reflect your development database, you'll need to run rake_db test clone, which will dump database schema from your development database and load it into your test environment. Let's clone our database. Do rake_db:_test:_clone, and we should be good to go. We now have a user model with its associated table, and we've ensured that it is also available in the test environment when we ran db test clone. So now we can run rspec on the models directory again and see if it runs. Excellent. Looks like our user specs are ready to be filled up with some examples. Let's do a quick check on Trello for what we're supposed to do. Okay, looks like we'll need to ensure that our user model has a name and an email. Let's write those specs. In our spec, you write tests by first describing an object and then specifying what it is expected to do. The describe method creates an example group, and within it, you can declare more nested groups using the describe or context methods. To declare an example, you would use the it or specify methods. You can check out relishapp.com to find out more about our spec and also some examples on writing those specs. Here are some examples for controller specs, model specs, and other specs you might need for your app. Opening up our user spec, we see an RSpec describe block for a user class. When a class is described, an instance of that class is made available as an implicit subject to each example in that block. In the case of this describe block here, the implicit subject is the user model. So for this subject user, it is expected to respond to a method called name. We'll also say that this user is expected to respond to an email as well. Let's make sure our tests run before we start implementing the features that will satisfy this spec. Great! Looks like we've managed to write two failing specs, which we'll now try and pass by writing the code that will satisfy those specs. Before we do that, let's update our Trello board. So I've written specs for user should have name and should have email. I'll close this and move the specs for user model card to the done column. And let's pick the generate user model card and move that along to doing because, well, that's what we'll be doing. To pass the currently failing tests, we'll need to make sure that the user model responds to the name and email methods. It's useful to know that in Rails, the column names in your models database table map to methods of the same name in your model. So if your users table has a column called name, getter and setter methods of the same name will be made available to your user model, allowing you to do stuff like user.name equals to set the value for name and user.name to get the value from the name field. So this means that we'll just need to generate migrations that add the attributes name and email to our user model, and we should have passed our first two user spec examples. Thanks to Rails convention, adding columns and reversible migrations are easily generated using the Rails generate migration command. For instance, to add columns to a table, you might say Rails generate migration, add migration name to plural model name, and follow it with a list of column name and column type pairs. You might notice here a slight difference in how Rails names its models, which is in singular form, for example our user model, and how it refers to the table for that model, which in this case is called users. This is a convention that you'll need to get used to. So, to add the name and email columns to our user table, thus adding those same methods to our user model, we can say Rails G migration add name and email to users. Notice that here I use the plural form of the model name, string, email, string, and press enter. This will generate a migration called add name and email to users with a timestamp prepended to it. You could have just as well said Rails generate migration add columns to users followed by the attributes and still have created a valid migration. But it's always good to be informative in our naming, and since we're only adding two columns, generating a migration called add name and email to users will help any other developers working on your app to quickly identify what that migration is for without having to open it up to read through the generated code. Let's open up the one we just generated to make sure that it isn't just generating an empty migration file. Great. Looks like running this migration should add a name column and an email column to the users table. We'll run this for our development environment and also get it cloned over to our test environment. Then we can run our model specs again and get passing tests. Yay! We can now move this generate user model card to the done column and do the next card, which is just to play around with our new user model in a Rails sandbox console. We'll be creating and updating users in a sandbox environment so that our actual development environment database won't be modified. In a sandbox environment, all the transactions you do will eventually be rolled back so that nothing is really saved. So here I'm going to create some users and oh, hang on a minute. This is just the regular Rails console. Better not save anything at the moment. Let's exit this guy and run Rails console in sandbox mode. Just run Rails console, or Rails C for short, and add the -- sandbox option. This way, you don't have to worry about incomplete or incorrect data showing up in your development database. I'll try building a new user with user.new, passing it some parameters for name and email, and then save it to insert the data into the database. And here, I'll create another user using user.create, which builds and saves a user into the database immediately. I can also delete a user with user.delete. Let's try updating a user's attributes. Whoops, looks like I haven't initialized the user variable yet. That's because earlier I declared our new user to be assigned to a variable u instead of user. Let's fix that. I'll just let user be the user with the name Fadil, which I can find using Active Record's dynamic find method, in this case, find by name, and passing it the name of the user I want. Now, I can update attributes of this user object. Brilliant. Looks like we've got a proper working user model which we can use to create user objects that we can then save to the database. Let's done this card and head on to our next task, which is to add validations to the username and email. We want to ensure that when a user is created, it should always have a name and an email, and the email should be formatted correctly. In our user spec, we'll now describe a block for when a user is created. So I'll say describe when creating user do, and add a context for when a user is created with valid data. If I specified an it block here, the subject for that example would implicitly be an instantiation of the user class with user.new, since we describe user as a class in the outermost describe block. This won't do, because user.new doesn't provide a name or an email. So we'll say let user be user.new and give it some valid data by passing it a name and an email. Now that we've set up a user variable, how do we use that as the subject instead of the implicit user.new provided by our describe block? Easy. We'll just say subject user, and then we can continue with our example by saying it is expected to be valid. Our specs should now be green again. Time to write some examples for creating a user with invalid data. We'll first ensure that a user cannot be created without a name. Let's add that context in here. We already have a with valid data context, so it would make sense for us to have a with invalid data context for cases where a user is trying to be created without valid data. Under this context, we'll add another subcontext where name is blank to cater for cases where the user.new method is not passed in a name argument. We want to test a user without a name, so technically we should be able to get away without describing a subject and just let our example use the implicit subject user.new, which doesn't provide any arguments anyway. But for the sake of clarity, it might be better to explicitly provide a subject for our example with the specific parameter missing. So, for the context where our username is blank, we'll say let invalid user be user.new and pass it only an email, and then we'll set invalid user to be the subject. Finally, we can say that it is expected to not be valid. We can now run our spec to find some new red specs waiting for us. To get our new spec examples to pass, we'll need to validate the data that is passed to our user model when running new or create. For where name is blank for our user model, we'll want to validate its name and ensure that it is present. So we say we want to validate its presence. Set presence to true, so validate takes a method name and a validation helper. In this case, presence, which accepts a Boolean value true. You can check out other validation helpers provided by Rails at guides.rubyonrails.org and look for active record validations. We should now be able to run our spec models to get our model spec to pass. Let's also run rspec to run all of our specs for good measure. Now, to do the same for email, open up the specs file, add another context under the with invalid data context, this time with a context called where email is blank, and say that the invalid user is user.new with just a name passed in, and make that invalid user the subject of this example, and say that it is expected to not be valid. Let's run these specs. Uh-oh, looks like there's an error here. It says there's an undefined method is underscore expected underscore to underscore not. Of course there isn't. The method is actually is underscore expected, which actually just returns expect subject. So let's fix this. Now we run our spec again, and there we go, a proper failing spec. Since we've updated the implementation for one validation, let's also update our Trello cards. Now, to implement validating email to not be blank. Opening up our user model here and make sure that it validates email, the presence of which should be true. And running our specs again gives us all green specs. Hooray! Time to update the Trello board. There we go. We've got one more validation spec and implementation to do to clear up our two doing cards. Let's take a look at that spec for user validation card. It says here email should be a particular format. Let's further define this so we know just what format we're looking for. Let's keep things simple and say we're just expecting an email to have an @ symbol and a .domain at the end. Excellent. Let's get cracking. First, the spec examples. Let's add another context under the with invalid data context for a context where email is fadil.lukman@gmail.com, which is an invalid email because it is missing the @ symbol. We want that this sort of email not be allowed for a user. We'll let invalid user be user.new with a valid name, but with this invalidly formatted email address. We'll say that a user with an email with no @ in it is expected to not be valid. Let's also go ahead and do another context for where there is no top-level domain in an email address. The top-level domain, or TLD, is the .com or .orgs that you see in an email address. Let's just copy the previous context and replace the email address we're testing. Now, this has got me thinking. Maybe we should make sure that an email actually has a username before the @ symbol. Let's update our Trello card to reflect this new requirement. There we go. I think you should kind of get Trello by now. Update often and add details so your team knows what's up. Since you're by now probably Kanban masters, let's skip the Trello stuff for the rest of the video. Let's now create a context for no username in the email. Running our spec on spec models now shows 3 correctly failing tests for email format validation because we haven't yet implemented the validations for them. Before going on though, it looks like we're just repeating these examples and only changing the email input value. Let's see if we can't refactor this to dry it up. Dry, of course, being the philosophy of don't repeat yourself. So I'll create a variable called invalid emails, which is just an array of all the invalid email formats we're checking for. So we have one blank email, one without an @ one without a top-level domain, and one without a username. Now, let's iterate through each item in the invalid emails array by using the Ruby arrays.each method, which yields each item in the array into a Ruby block that should accept an item as its argument. Let's take a look at how an arrays.each method works on OmniRef. We'll try search for an array each. The third result from the top looks like the one we're looking for. Let's have a look. Ah, brilliant. There's a usage example here, and based on this, we should be able to rewrite our specs like so. Now, each email in our invalid emails array will be passed into our block as the argument invalid email, which we've specified in between these two pipes at the end of the .each do line. Now let's copy one of those where email is contexts and paste it in here to make it dynamic. First, we'll need to fill up each where email is context string with the corresponding invalid email string. In Ruby, you can have a string interpolate a variable when the string is enclosed in double quotes and the variable is encapsulated in a hash curly brackets notation like this. Let's replace the rest of the fixed email strings with the invalid email variable. Here, for every item in invalid emails, we'll create an invalid user with the invalid email item as the email argument in user.new. And then we'll let the subject be that invalid user and run the example where it is expected to not be valid. This looks about right. Let's comment out the original non-dry version of this example and rerun our spec models. Uh-oh, an error. It says here, syntax error, unexpected end of input, expecting keyword end. Sounds like I might be missing an end for one of my do blocks. Let's have a quick look at the code we just wrote and the code we commented to find out where we might have messed up. The examples we just wrote seem to look okay. Each do has its corresponding end. Maybe we inadvertently commented out one end too many in the code below that. Let's have a look. Aha! Looks like I accidentally commented one end more than I needed to. I'll uncomment that and rerun our model specs. There we go. You can see that the descriptions for the examples are filled in with each invalid email, and the user.new method for each also initializes users with the corresponding invalid email. We specified 4 invalid emails, but the first one, the blank email, is already being validated by our user model with the last validates method that we added to it earlier. So now we only need to fix validations for incorrectly formatted emails. Let's see if the validates method has any options for validating formats of an input. Let's check out guides.rubyonrails and check out active record validations. A quick look at the sidebar shows us part 2 is about validation helpers, which is what we're looking for. Go down from there and you'll see a link to format. This must be what we're looking for. Let's click that. Aha! It says that it validates a value by matching it to a regular expression using the with option. There's an example for usage here as well. Excellent. We'll use this to validate email formats. So our user model validates an email's format with, and here we need to give it a regular expression to match against, and it should give this message on error. Let's say the error message will say that an email must be a valid email address. Great. Just one thing though. What is a regular expression? Let's wiki this. Okay. So the wiki says that regular expressions, also called rational expressions, are a sequence of characters that form a search pattern, mainly for use in pattern matching with strings or string matching. If you've never heard about regular expressions before, you can read up more on the wiki. But now, let's see if we can't find documentation for Ruby's implementation of regular expressions. Googling shows us there's official Ruby docs for this. Let's see here. Aha! Looks like we found what we're looking for. So, according to this, we can start building a simple regular expression that can match valid emails. I know that regular expressions can match the beginning and end of a string, so let's see if that Ruby doc covers this. Scrolling down, we'll find a section called Anchors that gives us exactly what we're looking for. So we'll say from the beginning of the string, we'll want an email to have a non-white space character, since emails can't have spaces, and we'll want it repeated at least one or more times. Then we'll want an @ symbol, followed by another string of non-white space characters, also at least one or more. Then we'll need a dot. But hang on, a dot is used to match one single character, as it mentions here. But a little earlier in the page, you'll see a caveat for meta characters like dots and commas, which will need to be / escaped. So I'll say we're looking for an actual dot, and then another string of non-white space characters, which should then match the end of the string. Let's test out this regular expression of ours. When we were searching for Ruby regular expressions earlier, there was a link to Rubular, which is an online regular expression tester for Ruby. Let's copy our regular expression and test it out here. First, I'll put in a valid email, which it should be able to match. Excellent. How about if we get rid of the @ symbol? All right. It won't match when there isn't an @ symbol. How about without a TLD? Brilliant. So far, so good. How about without a username? Yay, that works too. Just for good measure, I'll try a username with a few dashes and a domain with a subdomain and see if that works. Awesome. Seems to work for most use cases that we normally encounter. Sounds like our validation specs should work by now. Let's run the model specs again. Eh? There's an error. Did I forget to save my user model file? I think I did. Let's save it and rerun the specs. Yay! They pass! Now, we'll need to spec out a user's controller, which will have the actions index, where we'll list all the users we have in the database, and show, which should show the details for a specific user. Let's start specking it out. First, we'll close all these tabs we don't need, and we'll get Rails to generate a controller spec saying Rails generate rspec:\controller users, since we're testing the user's controller. It should generate a user's controller spec under the spec/controllers folder. Let's open it up. Here, you'll see a describe block for a user controller class. We don't have one yet, so I suspect that running rspec on this user controller spec will throw an error. Let's give it a shot. Notice that this time I specified the full path to the user's controller spec file to rspec. This will run the examples from that spec file alone. If we had other controller specs and wanted to run them all, we would say rspec spec/controllers. As expected, rspec complains about the uninitialized constant user's controller. We saw something similar to this when first trying out our model specs, and the way to solve it is pretty much the same. We'll just have to generate a user's controller, which will create that class in a file under the app/controllers directory. Let's rerun our spec. Hooray! Looks like rspec managed to load our user's controller class, which was generated. Let's just take a look at the file for a bit so we know it's there. Yep, looks like we've got a good old bare bones user's controller class that extends application controller, giving our controller some standard methods that Rails uses for its controllers. Now, to write the specs for testing the index and show pages for our user's controller. First, let's find out how to write controller specs. Let's look it up on Relish app. Go to relishapp.com, look at public projects, search for rspec on the pages, and you should see a link to rspec/rspec Rails. Click that, and there's a link on the menu bar for controller specs. This looks about right. There's an example down here, and it looks like we can test the controller's response using response and variable assignments for a controller's action using assigns. At the beginning of this page, it mentioned that rspec controller specs are a wrapper for action controller test case behavior. We should be able to look for this on OmniRef to find out what that's all about. Let's just paste in that module name into the OmniRef search bar and see what it spits out. Aha! There's a link to action controller test case, which seems to include action controller test case behavior. So, according to this, you can use get, post, patch, put, delete, or head to simulate HTTP requests. We've seen examples using get on Relish app, but now we know we have a bunch of other requests we can test as well. There's a show more button here. Let's have a look. Here it says there are some special instance variables that are exposed for our testing as well. We've seen examples using response, but it looks like there is a controller and request variable as well. Excellent! Let's see what else we got here. Aha! There are some additional things we can use in our tests that seem to be called collections. We've seen the assigns example on Relish app, which is used to test variables assigned in the controller's actions, but there is also a session, flash, and cookies collection to test those very things. Brilliant! We might not be using all of these things just yet, but it's always good to know where to be able to find this sort of information. Back to our specs. I'll describe my user's controller spec to say that for the context of when you get the index action, it renders the index template. So in the it block, which is where our test actually lies, I'll use rspec's get method to simulate a get request on the index action, and I expect the response to render the template index. Now to run the spec. Great. Looks like there's an error here. It says no route matches the index action for the user's controller. Let's fix that. Once we've added the route, we can run our spec again, this time to see another error, saying that it couldn't find the index action in the user's controller. Let's define the index action. Running our spec again will give us a missing template error, which means we'll need to create the index template view, which is just an html.erb file called index.html.erb, which we'll create in the user's folder under views. By convention, Rails will look for a file with the similar name as an action in the folder with the same name as the controller. So this is a no-brainer. Now we'll finally be getting this example to pass. Let's do the same for the show action. Let's just repeat the process and we should finally get a passing spec with 2 examples. Now we just have one more thing to do, which is to actually show some information on the user's index and show views. The first thing we'll want to do is to provide a variable with the data we need that can be used inside our views. Let's spec that out. I'm going to say that for the getIndex context, we'll want to make sure that for our user's controller, it assigns a variable at posts. Before we do our test, we'll need to set up our test database to have some data to test. Here we'll create a couple of user objects, just give them some valid data, and then let's create an array with these 2 users, which is what a call to user.all should return. Let's see that at work in a sandbox database. I'll open up a new terminal here and run Rails console in sandbox mode. If I call user.all now, it just returns an empty array. I'll go ahead and create user1 with some valid data and a user2 object with another set of valid data. I'm technically just copying the lines from our spec. I'll also set up a users array which just contains these 2 users. Great. If I just call that users variable again, right, it shows me those 2 users. Now, what if I ran user.all? Remember, this is a sandbox database wherein the only data in it is the ones we just created. Let's see what user.all outputs. It says it's an active record relation, but after that, it looks like the data being passed back is simply an array of the 2 users, and it looks mighty similar to our users array earlier. Let's do a quick test to see if they're really the same. User.all equal users. This should compare the 2 and return true if they're the same. Aha! Looks like users is identical to user.all, which means our spec example has an object users that should technically be equivalent to all the users in the test database. Great. You'll want to make sure to exit the sandbox console because having it open will lock your database, and rakedb migrate won't work if it's still open. So now we can say, when we get the index action, we expect the controller assigns a users variable that equals all the users in our database. Remember, at the moment, the variable users that we're testing here is representative of all the data in the test database at the moment. Let's run this new example of ours. Right, it's obviously failing because our index action for the user's controller doesn't do the things our spec is expecting, which is to assign a users variable with all the users in our database. Let's fix that. We'll open up the users controller, and in the index action method, we'll set up a variable called @users, which gets all the users from the database, or in other words, user.all. Now we should be seeing a green or passing test. Bazinga! Now for the show page. Let's write the specs first, then do the implementation. Looking at our show page, it seems like we're lacking something here. For starters, since this page is supposed to show the details of one specific user, the app will need to know which user's details to get from the database. We know that we have an ID field on the user model which we can use to find a user with a particular ID, but how do we pass the ID to our controller and action so it can find a user? In Rails, you can easily send a parameter in your path or URL. Let's take a look at how this works at guides.rubyonrails. Look for the Rails routing from the outside in section. Brilliant. Looks like the very first section of the page addresses the very issue we're trying to figure out. According to this, you can specify that a section of your URL will be interpreted as a parameter, in this case matching an ID param, written as :ID in the path here. Any value in the place of that parameter will be sent to the controller's action as a params hash, like so. Right. So, in our spec, we'll create another context to say that we're testing getShow to see if hitting this getShow action and sending it a valid ID parameter will give us the user object with the corresponding ID. I have a context getShow here, so I'll add another context where show is called with a valid ID and say that it assigns a @user variable with a user object with that ID. So, before we actually get the show page, we'll need to make sure the test database is populated with some valid data that it can run this test on. Let's create a few users for this example. Instead of creating a user on each line like we did in the previous example, let's do this programmatically. So I'll say 3 times do n, and then I'll say for each of these n's, I'll create a user with the name user_n and the email userN@email.com. At this point, our test database will have 3 user entries. So we'll say when we get show with ID 2, we expect assigns user to equal the user with ID 2, which we can get by doing user.find2. Alright, this looks about right. Let's try it out. Awesome. We're getting a failing test that we can now fix. It says here it's expecting to find a user with ID 2, but it got nil instead. Let's give our show action the ability to find a user by the ID sent to it. Hey, what's this? An error? Hang on a second. Wasn't this test passing earlier? Let's see what the error says. It says, getShow couldn't find user without an ID. Oh, right. This is because when we wrote the spec for this earlier, our show page wasn't expecting an ID to be sent to it. It does now, so let's fix up our spec example for getShow renders the show template. Since show is expecting an ID, I'll just pass the getShow directive some ID. Let's say 1. Hopefully it should work now. Uh-oh. Looks like it couldn't find a user with ID 1. That's because we didn't create any data in the test database for that example. Let's go ahead and create one user, so that way there'll be a user with ID 1 that the show action can find. Yay! Our tests finally passed. This means that our index and show actions now have the appropriate variables assigned to them that can be used to display data in the view. We'll be looking at how to write feature specs using Capybara to spec out what we should see in a view in the next few videos. But for now, let's use our variables and call them in the views so we can at least see the fruits of our labor. So let's put a @users.inspect in a Ruby tag in the index view file and try to run the server and open the user/index page. Uh-oh, seems like it's giving us an empty array. That's probably because we don't have any data in the database at the moment. Let's try and create some users in the console, just so we can see it on screen. Create a couple of users here. And now, let's refresh the users index page. Oh yeah, that's more like it. Now let's do the same for the show page. Add a @user.inspect in the view, and then open it up in the browser and enter the URL users/show/1, meaning we'll want the data for the user with ID 1. And wait a second, what? This is certainly strange. Let's have a look at our routes. Aha! There's our problem. We don't have a route for show that takes an ID. We just have a regular users/show route. But that raises the question, how did our RSpec test pass then? As it turns out, when you access standard Rails resource actions like show, new, and edit, etc. in RSpec, RSpec would have already given it a resources route like the one here, and it should just work. So, To fix our error, we'll just add a route for show that takes an ID as a parameter and make sure that it routes to our user's controller's show action. Now let's try it again. Hooray! It works! You've successfully created a basic MVC pattern for user, where you have a user model and you have a user's controller that shows you the data from the model in a view in your browser. Excellent! In the next video, we'll add all this code into a Git repository and test setting it up on Heroku. We'll also create some forms to create new users and edit them as well.